भूल गए?
So I'm sorry, मैं भूल गई थी, मैं आज बना लूंगी.
खैर मैं ही बना दे रहा हूँ, कोई बात नहीं. So convex mirror is the one which is bulged out at the middle. Center of curvature will be on the right side. This is place called pole, and focus will also be on the right side. Distance, the light will always come from the left side, the real object. So not left side, it will always coming on the unpolished surface, or that is called reflecting surface. Focal length, the distances measured from pole in the direction of light is positive. So focal length of convex mirror is positive. Behavior of convex mirror is diverging. The light ray that comes on the convex mirror gets diverged. So it is behaving like a diverging mirror. Light incident parallel to the principal axis. After reflection, it seems to be diverging from focus. That is the first light ray. Second is exactly opposite of it. If the light ray is going through the, if light ray seems to be incident at the focus, after reflection it will become parallel to the principal axis. If light is seems to be going to the focus, so it is exactly again by the principle of reversibility. By the principle of reversibility, a light ray follows path if the object and image is replaced. Correct? Okay, third one is if the light ray seems to incident at the center of curvature, it will be reflected back along the same path by again using the same concept. Because if it is incident at the center of curvature, it is incident perpendicularly. So if light is incident perpendicularly, that means it will be retracing its path back. The fourth one is, say where we use convex mirror and where do we use concave mirror in practical life? Say
car के कैमरे में.
कार के कैमरे में? कार में कौन सा कैमरा होता है?
Sir, I think he means mirror, rear view mirror.
Yes sir.
Rear view mirror, side वाला mirror. एक बीच में लगा होता है वो back mirror, वो नहीं जो rear view के लिए होता है, that is a convex mirror, right? And the logic why it is used that because of the it has all the time image formed always will be there. There won't be any change in the position. The image will never disappear. It will always be in front of you, irrespective of the object. Whether object is at infinity, whether object is at focus, whether object is at center of curvature. So mind you, if you say that object is at equal to focus, then that is incorrect, because here the focus is not on the left side. Focus is on the right hand side. So that simply means an object is kept at a distance equal to focus. Focus point does not lie on the left side, so a real object is not placed on that. Real object is anywhere an object is placed, whether it is infinite distance equal to radius of curvature equal to focal length. In all the cases, the image formation will be always this similar position, which is called between the pole and focus. A light ray incident parallel to principal axis. Another one which passes through, which is incident at the pole. gets reflected back at the same angle. These two light rays seems to be intersecting behind the mirror and again between the pole and focus. So this image can be seen only when the light ray diverged will enter into some person's eye and make a real image at the retina. But that is the second case, how virtual image is seen. Now we are focusing only on this mirror, convex mirror case. So anywhere you put in front of the object, the image will always lie between pole and focus. Image is always virtual, erect, smaller in size, and between pole and focus. So it seems smaller than the actual size, and that's why it is written there that the object are nearer, closer than they appear. Because it seems small in size, so it may appear that it is quite far, but it may be just right next to your car. So the vision or the range of the vision is infinite. You start from the mirror till infinity, everywhere it will be the same thing. That's why it is preferred for any such places where we have to enhance the vision, like in the warehouses, at the metro station to see the whole train. मेट्रो स्टेशन पे क्या काम है इसका? मतलब मेट्रो स्टेशन पे कहाँ लगा होता है? मेट्रो स्टेशन पे कहाँ पे लगा होता है ये कन्वेक्स मिरर? विक्रमादित्य, have you seen this in the metro station?
Yes, sir.
कहाँ पे लगा होता है? Which place and what is the purpose?
सर आपकी आवाज क्रैक करके आ रही है।
आवाज क्रैक करके आ रही है। Viक्रमादित्य,
Yes, sir.
now is it coming?
Yes, sir.
Okay, so my question here is that where do we use in the metro station? Like what is the use of metro in metro station?
Not sure.
Yeah, answer maybe the mirror that's to see if the metro is coming from far away.
Sir, can I answer?
मेट्रो तो सीधे दिख जाती है यार। मेट्रो देखने के लिए मिरर की क्या जरूरत है? मेट्रो इतनी बड़ी है। कहाँ पे लगाता है मेट्रो स्टेशन
Sir,
पे?
can I answer?
Yes, yes, please.
Sir, these type of mirrors are used in around bends, around corners, so you can see ki what's coming from the other side.
My specific question was now for the metro station. In metro station, I'm just asking you a quick presence of mind. Why what purpose is used? Curiosity. Have you checked it or seen it or not?
So एक साल से metro station गए नहीं हैं.
अरे एक साल के पहले गए थे, मैं तो 4-5 साल से नहीं गया. So that does not mean this is a platform, suppose, where the person wait for the train. There's the track here. So it is hanging somewhere here, a big circle type where the train stops. So it is not for you to use, basically, it is for the train driver to use. Because of this is enhanced vision range, he can see all doors at the same time of the whole metro train. The whole train he can see in this mirror, and he can accordingly adjust the timing when you have to switch off the door, or all the doors are closed or not. He's ready to go. समझ गए? Understood?
Yes.
Okay. Similarly, at the intersection of at the intersection of the traffic and the warehouses, we have to use the convex mirror, right? Concave mirror कहाँ use करते हैं? Concave mirror कहाँ use करते हैं?
सर
Where do
डेंटिस्ट
you
करते हैं.
mirror? डेंटिस्ट यूज करते हैं, मेकअप आर्टिस्ट यूज करते हैं, और शेविंग मिरर के लिए यूज करते हैं, व्हीकल हेडलाइट का बैक यूज करते हैं,
Rear view mirror
Sir,
के लिए
street
use होता
lights.
है. Street lights.
स्ट्रीट लाइट में बैक में यूज करते हैं, करेक्ट.
Rear view mirror के लिए.
और
Rear view mirror के लिए.
रियर व्यू मिरर के लिए तो कन्वेक्स मिरर है. अब आज के लिए कनकेव मिरर.
Oh,
कन्वेक्स
sorry.
मिरर तो कन्वेक्स मिरर इज फॉर रियर व्यू. Okay. And rear view mirror in metro station, the traffic, anywhere like that. Okay, fine. So now one new mirror, that type of mirror that you might not have heard, parabolic mirror. I think last class we also discussed something about spherical aberration. Did we use this word? Did I use this word last class? Spherical
No,
aberration?
sir, I don't think so.
No? Okay. So when we have to draw the ray diagram, तो हम randomly कहीं से भी light ray show कर देते हैं. For the ray diagram, we choose any height, any position. Like we take light ray from here also. The light ray passes parallel, and the light ray will go through focal, becomes parallel. But when the practice, if we do so, then the image formed will be blurred. Why? Because we should not use this curve portion of this mirror. We have to always use the central part, which is almost like a plane mirror. Only this portion of mirror should be used. Only this portion of mirror should be used, because in this case all the light rays will be focused at same point. So the light ray which comes closer to the principal axis are called paraxial rays. So all the time for ray diagram, though we will represent it by all the distant light rays, but paraxial rays are closer to the principal axis, and all paraxial rays are focused at same point. Right? All paraxial rays are focused at same point, but if we are using more curvature, then the light ray coming from the curved portion will not be focused at the same point. So that will cause a blurred image, and that defect of image is called spherical aberration. Right? Okay. You understood this or not? The rays which are coming from larger distance are called marginal rays. Marginal rays are coming from distance, and all paraxial rays are coming closer to the principal axis. Correct? So paraxial ray approximation is that all the light rays should come closer to the principal axis. All the light rays will be focused at the same point. If it is focused at different point, then the light ray formed will be image. The image formed will become blurred, and that defect of image is called spherical aberration. Correct? बेटा इस में आ गया क्या? Should I explain more or you understood? किसी भी मिरर के केस में अगर हम बहुत बड़ा सा उसका कर्वेचर यूज करेंगे, then the problem is that light rays are not focused at the same point.
Sir, ये समझ में आ गया, but how does marginal rays and parallaxial rays affect the thing?
How marginal rays and parallel rays are?
How do they affect the image?
See, the problem is that the light ray which will be incident at the paraxial rays will be almost at a very, very zero angle. But the light rays which are coming from the larger distance, like marginal rays, the angle will be bigger, so it will be deflected slightly more. So this is for the paraxial light ray convergence point, and this FM is for the marginal rays. So the marginal rays will be focused near little bit closer than the paraxial rays, and therefore their focus point will be different, and their focus point will be different. So their image will be formed at different point. It will be a blurred image. Each point has an image, but from the different portions. So जब हम इसको experiment में करते हैं at the higher level, we cover the whole portion by black paper. Only the middle central part is used to avoid the spherical aberration. So
Okay,
spherical aberration क्या है? Due to the larger curvature of the mirror. See, I'm not restricting only to the lines written in your book because that's not the idea of my class. You should understand the concept because you will get to see these words also in some books. Due to larger curvature of spherical mirror, the image formed is blurred. This is called spherical aberration, right? अब spherical aberration avoid करने के लिए क्या करते हैं? अगर concave mirror convex mirror use करें तो हमें एक बड़ा सा कुछ black paper से cover करना पड़ता है. Only central portion is left.
सर मेरा एक डाउट था.
बोलो.
सर अभी हम रिफ्लेक्शन कर रहे हैं, बट मैंने अभी अपने टेक्स्ट बुक में चेक किया है कि रिफ्लेक्शन का तो कोई चैप्टर है नहीं. इट्स रिफ्रैक्शन ऑफ लाइट एट प्लेन सर्फेसेस, रिफ्रैक्शन थ्रू अ लेंस एंड स्पेक्ट्रम.
Good morning, Jayesh. Good morning. 2 क्लास हो चुकी है, and I think now you are.
सर मैं एक क्लास में एब्सेंट था.
नहीं, उसके पहले भी 3rd4th क्लास हो चुकी है. I told you that I will start from the very basic of light, class 9th. First being online, second you are not with me, and third I don't know how much that part is retained in your memory. So because all of that will be required here, that all will be required here, and hence required in this second chapter. Second chapter, as in when we do the less converging and convergence and divergence, that meaning we should understand, and I will relate both of them also, converging mirror and converging lens. So that is why, right? That is why
मुझे
we are
ये डाउट इसलिए हुआ कि मैं नोट डाउन करे जा रहा था, बट देन मुझे याद आया कि टेक्स्ट बुक में ऐसा चैप्टर नहीं था. सो जस्ट वांटेड टू चेक.
हाँ, कोई बात नहीं. So I do not want to jump because that is not the idea of my class to finish the lines written in your book. Okay, and because I asked questions and nobody was able to answer correctly, that's why I started from the very basic. This is the actual chapter, which was initially one single chapter, is now broken into 2 parts. reflection in 9th, refraction in 10th. But again, some portion will be using reflection like the silvered lens and silvered faces. So I wanted to do it from the scratch. Very nice. And I think the schools are, we are at par with the school, or at least matching in the syllabus with the school. So there is no rush. I don't want just to read these lines and do the questions at the back that any XYZ can do. You can also do on your own. But that teacher is not required. Right? Chalo, continue. So post में नहीं है because this idea is not to just finish the syllabus or chapter. It is to open your broad, open your horizon, open your understanding, and that's how it will be understood well. चलो, very good. आगे बढ़ते हैं. So अब आते हैं वापस पॉइंट पे. हमने स्फेरिकल मिरर रिलेशन क्या पढ़ा? जब भी हम कोई कर्व्ड मिरर यूज करते हैं, अगर बहुत बड़ा सा पार्ट ले लेंगे, then different light ray will be focused at different point. And that is why sorry, and that is why we have to use only the shorter part of the central part of the mirror. If we want to avoid this, another option is we use parabolic mirror. Now, where is the parabolic mirror? If you can relate, all the dish TV antennas, on what principle they work? That DTH or Jingalala type things. Yes. So there is a mirror. The signals come, and they all will reflect from all the part, and they have to always get received by the receiver at the focus. This is what dish antenna. It is also called as dish type antenna, which we use for the TV and all. So there the mirror is reflecting the light or other signals coming from all the direction, all the angle. So इसके लिए हम use करते हैं parabolic mirror because parabolic mirrors do not have what? Spherical aberration. Light ray coming from any part of the mirror will always be focused at the same point. Right? बेटा समझ में आ गया ये? Spherical aberration क्या होता है? If we use larger curvature, then the chances that the image will be blurred because the different part light rays will not be focused at the same point. Very nice. So now we'll come back to the lens diffraction. Don't worry, mirror. Something that I wanted to teach is that there are some spherical reflection, some mirrors. There are some image formation, and now we'll be using this also. We will also be using this in the case of lens and mirror. So now we can jump to class 9 because you guys are getting a little impatient. So we can start with refraction of light. Now you can see this word in your book, so you'll feel comfortable, I guess. So first phenomena was reflection when light is incident on a polished surface or when light is incident on any boundary. Light will always be reflected back into the same medium. Light will always be reflected back into the same medium, but some part of the light will also go in the second medium depending upon the density and all. Correct? So when light is incident on a medium boundary, from one medium to another medium, the light goes and light deviates from its initial path, and that deflection is called as diffraction of light. अब इसमें एक दो चीजें थी क्या? Light should be incident obliquely. So the exact words will be when a light ray is incident from one medium to another medium obliquely. When light is incident on a medium boundary obliquely, it deviates from its original path, and this phenomenon of deviation of light is called refraction of light. So it will be either bending towards the normal or it will be bending away from the normal, depending upon from what type of medium. So suppose in the second case, it is coming from some denser medium to rarer medium. Maybe it is coming out from glass to air. So from glass to air. Air to glass. And from glass to air. Angle I, angle R, angle I, angle R. So पहले तो phenomena समझते हैं. Phenomena क्या है? If you want to write, please write. When light ray is incident obliquely, when light ray is incident obliquely on the medium boundary, on a medium boundary separating two media, on a boundary separating two media, it deviates from its original path. On a boundary between two media, it deviates from its original path. It deviates from original path, and this deviation or this bending of light is called this deviation or this bending of light is defined as, so this deviation, not necessarily bending, this deviation in the path of light ray is called refraction of light. So रिफ्रैक्शन के लिए दो कंडीशन आ गई. पहली क्या, रिफ्रैक्शन तभी होगा जब दो अलग अलग मीडियम की बाउंड्री हो, एंड सेकंड, the light should be incident obliquely. Light should be going obliquely from one medium to another medium. So if it is going from air to glass, means it is going from rarer to denser. और ये rarer denser हमने कैसे decide किया? This is based on their intensity. This is based on their density, optical density. Deviation in the path of light ray is called refraction of light, and this depends upon the density. So अभी हम denser और rarer बोल रहे हैं किसको? जो optically dense है वो जिसकी density ज्यादा है. So like water is more dense than air, water will be denser. It will also be called as optically denser. Right? Deviation in the path of light. So rarer to denser, light will be bending towards the normal. If it is going from denser to rarer, so any case, not just, but it is not necessarily कि जो materially dense हो या जिसकी mass density ज़्यादा है वो optically dense भी हो. For example, the kerosene oil. Kerosene oil water से denser होता है या rarer, मतलब density wise? You know what is kerosene oil?
Yes, sir.
Kerosene oil पता है ना?
Yes, sir. वो airplanes में use होता है.
इसमें?
Airplanes में use होता है kerosene.
नहीं यार, एयरप्लेन में इतना घटिया फ्यूल थोड़ी यूज होता है. असल में एविएशन फ्यूल यूज होता है, दैट इज व्हाइट पेट्रोल. वेरी हाई ग्रेड प्रोडक्ट, उसमें यूज नहीं होता. घर में लकड़ी जलाने के काम आता था पहले. केरोसिन इज वेरी लो क्वालिटी फ्यूल. ओके ओके, अनदर एग्जांपल, आप पेट्रोल भी ले सकते हो बाय दैट मैटर. पेट्रोल इज आल्सो लाइटर देन वाटर, क्योंकि अगर वाटर के ऊपर पेट्रोल या ऑयल डालोगे तो उस पे ऊपर फ्लोट करता है. राइट? It floats means obviously it is obviously it is correct. Obviously it is lighter. So जरूरी नहीं है कि जो materially dense हो उसकी density optically भी ज्यादा हो. Rarer medium में जो भी light ray आ रही है, the light ray which goes from rarer to from the initial direction, it will bend. So incident light ray, at the point of incidence we draw normal, and then it is called refracted ray. The refracted ray will be bent towards the normal from its initial direction if it is going from rarer to denser. If it is going from denser to rarer, then from the initial direction it will bend away, and this total angle from the normal is called angle of refraction. I is angle of incidence, R is angle of refraction. So as we also discussed in Newton's corpuscular theory, that Newton assumed some hypothetical assumption that denser medium attract and rarer medium repels without any logic behind that. Right? Okay. Correct? Fine. So refracted light ray is always bent towards the normal when it goes from rarer to denser medium. So I think we did this also, but quickly we can write when light goes from denser to rarer to denser, it bends towards the normal. अब इसका actual reason क्या है वैसे, by the way? What is the actual reason? I think earlier we discussed. What is the actual reason for this?
So light always it always takes the shortest path.
Yes, and in the denser medium speed is less, so it also wants to take the lesser path, the shorter path, and that is why it bends. Right? Fine. It goes towards the normal, and the second case is when light is going from denser to rarer. But if suppose it is incident perpendicularly, then there won't be any change. The actual reason is because of the change in speed of light, speed becoming slower, so light wants to take the shorter path because it wants to cross in the shortest time. And when light goes from denser to rarer, it bends away from the normal. Fine. So in this case, we have two laws of refraction. What is the angle of deviation also in this case? So there is some deviation. Deviation means from the initial incident direction and by what angle it gets deviated. Here also, this is the angle of deviation. Right? What is the difference? What is the angle of deviation? Angle of deviation is angle between incident light ray and the emergent or refracted light ray. If light is incident perpendicularly, if light is incident, when light is incident perpendicularly, first case is when light is incident and then it goes away, and when light goes from denser to denser, bends away. Second is when light is incident perpendicularly or along the normal. When light is incident normally on the boundary of two media, it goes undeviated. Right?
Yes, sir.
So the second point essentially just means ki when it's coming exactly in the same line as the normal.
Yes, it will be in the same line along the normal. Second point means if it is along the normal, then it does not matter whether it is going from denser to rarer or it is going from the denser to rarer or rarer to denser. It will be exactly the same. Is your dotted portion? This is, I'm just trying to show that it is a denser medium like the glass or something. So if it is incident perpendicularly, it will go in the same direction. There won't be any deviation. So in this case, there is no deviation, there is no refraction taking place, there is no bending or change in the path takes. Yeah. So if we include the law of refraction, there are two laws of refraction again. Laws of refraction. First law is that again the incident light ray, the normal at the point of incidence, and the refracted light ray, all three will lie in same plane. The incident ray, normal at the point of incidence, and reflected light ray. All three lie in same plane. Second law is called Snell's law of refraction. Snell's law is that the sine of angle of incident, sine of angle of incidence to sine of angle of refraction is constant. If the first medium refractive index is mu1, second medium refractive index is mu2. Now, what is refractive index? That also we will define separately. But first, it is called Snell's law of refraction. The second law is also called as Snell's law, and it says that the ratio of sine of angle of incidence, the ratio of sine of angle of incidence to sine of Angle of refraction. Sine of angle of refraction is defined as is a constant for a pair of medium. And called as refractive index of second medium and called as refractive index of second medium with respect to 1. Refractive index of second मतलब जिसमें light बाहर निकल रही है and first through which the light is coming. Refractive index of second medium with respect to first. Sin I by sin R. इसको लिखने का तरीका mu 2 1 होता है या it is also written as 2 with respect to 1. That light is coming from 1 and going into medium 2. Sin I by sin R is equal to mu of 2 with respect to 1, and that value is a constant value for a pair of medium. Snell's law for refraction. What is the angle of deviation? Angle of deviation in the angle of deviation caused during the refraction, whether it is going from rarer to denser or denser to rarer, it is I minus R mod. Mod का मतलब जो बड़ा होगा उससे छोटे वाले को सेपरेट कर देंगे. Right. Angle of deviation is the angle between the incident light ray and the reflected light ray. Correct. So this is the what is the cause of reflection, by the way? Come again. What is the cause of reflection, Agastya?
The cause of refraction, it's a difference of speed between two mediums, and that light always takes the shortest path possible.
Shortest path. It will take least time to reach. Very nice. So there are a few more points at this. In the refraction, because refraction is not possible without reflection, because it is a medium boundary. So some part of light will always be reflected, and then only refraction will take place. So it is not possible that the 100% light gets refracted. 100% reflection is possible if we polish that surface. There is no light going in the second medium. It is reflected ray, and here it is refracted ray. So there are some common points, star mark and right. Some part of light always goes back to the same medium. Some part of light is always reflected back into the same medium. Is always reflected back into the same medium, but and this always follows the laws of reflection. Following the laws of reflection, only the remaining light will be transmitted or refracted. Only the remaining light is transmitted, or only the remaining light suffers. Only the remaining light enters into the other medium. So इसका conclusion क्या हुआ? The intensity of refracted light will always be less than intensity of the refracted light ray will always be less than incident. So there is always partial reflection and partial refraction at any medium boundary. There is always partial reflection. So that is why when we see any water body from the surface, there is a reflection like a mirror, and that is why we can also see our face in that mirror. It acts like a plain mirror only. There is always partial reflection and partial refraction. 100% refraction is not possible. 100% reflection is possible somehow, and that also we will see, called as total internal reflection. Right. So another result of this is that light intensity will be reduced. So intensity of the light which is transmitted is always less than the incident light. Another point is that the intensity of, what is intensity? How we define intensity? Say, what is intensity? What does intensity mean? Like definition of intensity? Say,
Sir,
what is intensity?
नहीं
Anyone? What is intensity? Yes, yes. What is intensity?
Sir, the amount of light. Like,
Amount of light. That is energy. Amount of light or what? Like complete the statement. Amount of light incident per unit area per unit time. That is called intensity. So इसको हम अलग से separately लिख लेते हैं because this word we'll be using multiple times. Intensity is defined as energy incident per unit time per unit area per unit time. So intensity is total energy. वो कैसी भी हो, light की energy हो सकती है, वो heat की energy भी हो सकती है, per unit area into time. E divided by A into T, that is the intensity. Energy is joule per meter square into second, or joule per second is watt, so its unit will be watt per meter square. That's the meaning of intensity. So here that energy, somewhat energy is reflected back. Intensity of refracted light is always less than intensity of incident light. Reflected light is always less than intensity of intensity of incident light. Right? Okay. So when the light is incident in the medium boundary, it will be moving away from the normal or it will be moving towards the normal. That is the angle of deviation. Now let's come back to refractive index and speed of the light in the different medium. Speed of light in the medium depends upon what? The speed of light in the medium. In any medium, on what factor it depends? It depends upon. So in the wave, speed is frequency into wavelength. Wavelength is the distance covered and in 1 unit time, and f is the frequency. So f को 1 upon t लिख लेंगे, that becomes speed distance upon time. F is frequency of light. What is the meaning of frequency of light? Like, what does that mean? Yes, yes. What is the meaning of frequency? Frequency is the number of oscillation per second. Number of oscillations per second. So इसमें oscillate क्या कर रहा है? इसमें oscillate कर रही है electric field and magnetic field. There is no particle oscillating. There is no particle oscillating. Right? Very nice. F is frequency of light and lambda is wavelength. और wavelength हम बात कर चुके हैं. Wavelength of different part of light. Visible light is different, and wavelength is a differentiating factor, whether it is a blue color light or whether it is a red color light. Speed is frequency into wavelength. Now, when light goes from one medium to another, in these two things, frequency of light depends upon source. So जैसे हम sunlight की बात कर रहे हैं, so for all the colored light, whether it is a red, whether it is a green, violet, yellow, the same source. So that's why frequency जो भी किसी एक color की है वो same ही रहेगी. Like light goes from one medium to another, the source is still sun only. It has not changed. Lambda is wavelength. Wavelength किस पर depend करता है? Wavelength depend करता है medium. Wavelength depends upon medium and the frequency depends upon the source. When light passes from one medium to another, what will happen? Frequency will remain same, wavelength will change as per the speed change, because the cause of refraction is speed change. Speed change का मतलब है कि इन दोनों में से कुछ तो change हो रहा होगा, but we are saying that as long as source is same, frequency is not going to change. Red color की जो frequency air में थी, red color की same frequency होगी under water and in glass as well. The lambda will accordingly change as per the change in the speed. So when a light ray gets refracted, from rarer to denser medium, its speed decreases. From rarer to denser medium, the speed of light decreases, therefore wavelength decreases. Speed of light decrease क्यों हुई थी वैसे, by the way? Denser medium में जाने पे speed of light decrease क्यों हो रही है? Any idea? Any explanation why it is getting less? Very nice. Speed of light decrease होती है density medium में, because density medium has very close packing, so it maximum electric field जो oscillate हो रही है वो absorb हो जाती है and it does not have freedom to go. This is because of electromagnetic property. So light ray जब refract होगी from rarer to denser medium, speed of light decreases, hence wavelength decreases by the same factor, but frequency remains same. Wavelength decreases, but frequency remains same, and the reason is because the source is still same. चाहे light एक medium से दूसरे medium में गई है, the source of light has not changed because the source is same. because source of light is same. So what will be when light goes from denser to rarer? Exactly opposite. When light goes from denser to rarer medium, then the speed of light decreases and therefore wavelength decreases. From denser to rarer medium, the speed of light decreases. Speed of light decreases, therefore wavelength decreases also. So इसका मतलब ये है कि जो रेड कलर की वेवलेंथ हवा में है वो वाटर के अंदर रेड कलर की वेवलेंथ नहीं होगी, it will change. Wavelength decreases by the same factor. And frequency remain unchanged. Correct? Frequency of light depends upon source and the medium, and the wavelength depends upon the properties of medium. The frequency of light depends upon source and wavelength depends upon medium. Correct? Okay. Refractive index क्या था? Refractive index को अब हम फिर समझेंगे. What is a refractive index? Refractive index is a constant, but जो अभी हमने sin I by sin R लिखा था, that was relative refractive index. Now I will talk about the absolute refractive index. So next वाला heading, absolute refractive index. Absolute refractive index of the light of a medium. So it also depends upon the which light we are talking about for the different color of light. Absolute refractive index or just refractive index of a medium that we are denoting here by. It is defined as the ratio of speed of light in medium 1 to speed of light in medium 2. Speed of light in medium 1 to speed of light in medium 2. So light is going from medium 1 to medium 2, then it will be mu 1 2 become V1 by V2. तो जो हमने वहां पे कैलकुलेट किया था sin I by sin R, अब यहाँ पे ये mu 2 1 की जो हम बात कर रहे हैं, this is for relative refractive index. जब absolute medium की refractive index की बात करेंगे, absolute refractive index is speed of light in vacuum or air to speed of light in that medium. This is refractive index of medium 2 with respect to 1. Refractive index of medium 2 with respect to 1. Absolute refractive index का मतलब जो बाहर कोई और मीडियम नहीं है, जब कोई मीडियम नहीं है तो हम उसको यूज करेंगे as a vacuum. If there is no outside medium, that can be considered as vacuum. और वैक्यूम में स्पीड या एयर में स्पीड एक ही होती है, so हम उसको यूज करेंगे. Refractive index is absolute refractive index is speed of light in air or vacuum to this Speed of light in air or vacuum. Divided by speed of light in that medium. जिस medium का हम refractive index calculate कर रहे हैं, speed of light in that medium. Air में या vacuum में speed को हम c से denote करते हैं, and in that medium speed is denoted as v, so mu is equal to c by v. Mu is equal to c by v. So c is also a speed, v is also a speed. It will always be greater than 1. First of all, absolute refractive index is always greater than 1, and it is dimensionless. It has no unit because speed and speed get cancelled out. It also tells the idea about how many times faster the light is moving in any medium, faster or slower than particular medium. Vacuum के respect में, with respect to vacuum, with what speed it is how many times it is able to move. Right, so we'll continue from here next class. अभी मैं आपको सिर्फ एक worksheet देता हूँ छोटी सी for a pulley and all. Worksheet number 6 करी थी last class. Last class में worksheet number 6
वर्कशीट 6 किया था और वर्कशीट 5 होमवर्क था.
So worksheet 6 क्या था? Worksheet 7. So worksheet number 7 I am sending it. It is 15 minutes of a very small worksheet. And I hope you are sending copy directly to Shristi ma'am. She is updating me your result as well. Right. I've just shared a worksheet number 7 for pulley. Please go through it and solve. Submit in next 15 minutes. Okay, just got the message. Shublata ma'am is not well, so she won't be able to take class.